Do PTP and Blackburst really make a perfect pair? For years, broadcast engineers have all been using Blackburst, and then IP came along, and then the introduction of media over IP, and now most facilities, we're all having to gradually migrate from SDI to IP. Is there a culture class? Do they really make a perfect pair? Over to you, Steve and Kevin.
Hello there, Steve.
Hey, Kevin, how are you doing?
I'm good. We haven't done one of these for a while, have we? So,
Yes, it has been a little while. And liable to be another gap because of IBC coming up.
oh yes. So, for those of you coming to IBC, there's a little sneak about what we're up to. But this one's slightly different today. So we're going to sort of really chat about some of the stuff to do with references, how they're generated, why you need them. And there's the first question. Why do we need reference signals? Steve.
Yes. Well, Kevin, so the whole thing about reference signals, the whole reason they came about is because when you have multiple things coming in and you want to be able to switch between them, the video from one camera versus the video from another camera or a play out deck all need to start at the same time. Otherwise, if you switched from one video source to another video source, you might come down halfway down the video or halfway slid over horizontally. So we need to be able to go between multiple sources and have the switching be seamless.
Because obviously, simply in that state that where you should actually cut the video is a very small window in the vertical interval.
Yes, yes.
So if they're not timed,
yeah,
we have our first quality of service issue.
We most certainly will. And then different things have come along from Blackburst. We came out with tri-level, and now we've come out with PTP. So we've got multiple things and multiple ways to look at this.
And most of our customers are also now having to take signals that are coming in from remote locations. They're cutting between multiple venues and that. All of these have to be timed.
Yep.
So should we start with the first one that I was certainly introduced to when I came into the industry nearly 30 years ago, Blackburst.
Yes. Or as we say in the States, Blackburst. So
lovely waveform picture of it.
Yeah.
Exciting, isn't it?
So Blackburst, black meaning the sync pulse for the reference, that is at 0. Remember, this was back in the analog days, so this was an NTSC reference. And it gave us a reference of where black video would be. And it gave us color timing. So that's the burst. The burst is the NTSC color or the PAL color timing.
And it's fascinating that this signal has just not gone away, has it? It's still there.
It is still there. But a new signal has kind of emerged a little bit, which is tri-level sync. And why did we end up going to tri-level sync, Kev?
Well, my first experience of this is when HD came on the scene and was going to simplify our life with one standard and everything was going to be good.
Yeah. Well, since we went to HD, but we've got so many different flavors of HD from a repetition standpoint. You got 1080i, 1080p, 2398, 23976, 24, 50, 25. We've got all these different repetition rates that aren't necessarily whole integer values. Some of them are, depending on what side of the pond you're on. And the tri-level sync gave us the reference at the frequency of the video. And some people can play with the math, but if you take 1080 and you take 525 and you divide those into each other, so if you take 1080 and you divide it by 525, you'll find out that it's 2.14 blah 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 blah. It's not an even multiple, so we can't line lock with Blackburst. We can frame lock, but we can't line lock. So the line lock has to be derived in the receiver itself if you time your system to Blackburst. And then from a reference standpoint, every time you change on your SPG, you change the line count trying to time things, it will move two lines at a time in HD. So it's kind of unique. The other unique thing is that tri-level goes negative by 300 millivolts and then goes positive by 300 millivolts. And what you're actually seeing is it removes the DC offset. So if we were to continue to pump that thing negatively like we do in Blackburst at the high rates we do for like 1080p, it would actually put a capacitive charge on the cable and would start taking our reference, and our reference would actually start dissolving on us, the black, because it would take on a DC charge.
Yeah. So the other one we now see is obviously SDI, and SDI black and SDI color bars. And you and I have had personal experience of this at IBC and NAB with certain video players that require this as a reference. Otherwise, you get nothing out of them.
Yes. So some devices want actual SDI to lock on. I've seen that in a lot of the little playout devices that are playing off of either a card or playing off of an SSD, and they generally want black to sync their output so they aren't drifting in time. So black and either SD, HD, SDI black, or even color bars can be a reference signal.
That reminds me, I must add that distribution amplifier to the list of equipment for IBC.
One more change.
One more thing. So we talked about video, but we've also got audio, and they've got reference signals as well.
Yes. Like anything else, it's got to be timed because we don't want an interruption and we don't want to break audio up when we do a change of one video source to another. You can't have the audio glitching and popping and making a bunch of noise. So we have to have the reference signals if you're not doing embedded audio, and if you're doing baseband audio before it gets embedded, we need to be able to sync that so that it's in the proper place. So when the switch point comes up, we switch.
And obviously the final one on this is LTC.
So
longitudinal time code.
Yeah. So LTC's been around forever. The unique thing about time code is technically it only counts to 30. Other people do things to time code to make it count past 30, but LTC itself, bitwise, can only count to 30. It was made originally for 24 frame video and being able to time things at 24 frames. And that kind of leads us to what's going on with an SPG. How do we sync all this stuff?
Yeah, because obviously we're running on a nice little box that's got everything inside it, running off of an internal oscillator. But as we alluded to earlier, most of our customers will now have a wide area campus where maybe they've got several studios spread out, and you just physically can't do this. You have to have multiple sync pulse generators, and how do you lock them together?
Yes. So the nice thing about GPS, regardless of where you're at, everything you come up with will be in time with one facility versus another facility. It's the beauty about how GPS works, is it will be in time. The unique thing these days is there's at least 5 different, what they're now calling GNSS constellations for GPS being able to lock the things. The US has got the GPS system. We have a system for Japan. We've got a system for China. Got a system for Russia. All of these different countries have built their own GPS system. And one of the nice things with the newer sync pulse generators is we can lock on multiple systems. And especially during like rain fade, each one's a different frequency. So if you do live in an area where you have super, super bad rain fade, you might lose one of your GPSs. The others will be on a fractionally different frequency and keep you locked, and you'll stay locked to GPS across as the rain fade goes through.
Excellent. So we have to switch. Oh, I was going to say, do you want to switch to your unit and show people this connected?
Sure.
Because it seems like a good point to jump in here. So this is on Steve's leader LT 4670, and as you can see here, it's detailing the various GNSS systems that it's connected to, and it's detailing the number of satellites it can see, and this is in real time.
Yes. So you can see it walking back and forth. Satellites are in a low Earth orbit, so they are not geosynchronous. They are moving. So a satellite moves in, the satellite moves out of view, and you'll see them pop in and out. And one of the very unique things here is, for the US system, I've got 10 birds I'm looking at. For GLONASS, I've got 6 birds I'm looking at. For Galileo, I've got 9 birds. And then for BDS down here, I've got 6 birds that I'm looking at. And it actually, the sensitivity is actually incredible, considering if you look at this picture, there's my GPS antenna sitting right there inside my office. So I don't even have my GPS antenna outside. I've got my GPS sitting on a shelf right behind me inside my office. Now I am on a 2nd floor of my house, but I also have a concrete tile roof. So it's amazing that we get this many birds without me drilling holes through my house and having to stick the antenna out someplace.
Whereas over here in the UK, in my Victorian brick-built cottage, I have to stick it out the window. So, right, well, that's a great explanation of that. Obviously, things have improved on this, but you can still have a situation where you can't get GPS. So how do you sort of lock these devices together if there is no GPS reference?
Well, there's multiple ways of doing this, Kevin. So there is an internal mode where, and this is used quite often, especially with trucks at different venues where the truck may be underground or under a canopy or under something where it can't get GPS. And the SPGs have an internal oscillator that is an oven controlled crystal, so incredibly stable, and they're perfectly capable of working standalone, but they will not be in time with other devices outside of the venue. Then we also have the ability to genlock the SPGs to different external sources other than GPS. Blackburst tri-level is one. 10 megahertz continuous wave, CW, would be another. And good old PTP, we really haven't talked about too much yet. We're not going to get into the nitty gritty of PTP in this. We're really, in this series, we're just talking about how do we deal with PTP and all the rest of the things the SPG is doing and keep everybody happy. So how can GPS be used as a reference source, Kevin?
So it's actually a very cost-effective way of, if you've got a campus and you've got an IT network, that you can simply go through a network switch and you can start to lock studios to the SPG that's in your master control room that's got a GPS antenna connected to it. And we've shown this a couple of times at trade shows, where if you pop up the next animation, Steve, we've actually demonstrated the Blackburst master signal coming off of our primary, and then channel 2 being locked to PTP. And basically, for the 5 days of a show, those two signals did not move. They stayed locked together. So it's a very effective way of using PTP to lock SPGs together.
And it will take the accuracy of what the top SPG is locked to. If it is locked to GPS, you will have a GPS quality lock on the second SPG at the bottom. If it's locked to black, you'll have the accuracy of black. So whatever your lock is, PTP will bring that same lock quality down to the second SPG in doing this. So as I kind of alluded to there, we can lock to analog and Blackburst or tri-level. It is not as good of lock as GPS by any means. It's because the accuracy, the repetition rate is much slower than coming off of the time base that we can use for GPS.
So the question I frequently get asked by broadcasters, I've got NTP. I've used it for years. I use it to time all of my computers inside my facility. Why can't I use NTP? Why do I have to put PTP in? And I'm hoping this slide explains it to everybody, that there are a couple of challenges with NTP. And the first one is that, unfortunately, it's not accurate enough for us.
Yeah, we need sub microsecond or microsecond timing. NTP's in the millisecond range, but it's also a system where you have to go pull it and then it returns. So it isn't force fed to you like other synchronizing signals. So when we get black or we get GPS, it's coming at us at all times. And it's coming at us at a continuous rate that we can rely on. NTP only comes back whenever you go out and request it. Now, locking a clock, as long as I lock a clock on my computer within a second, I'm happy. Don't care, if it's off a few milliseconds or not. But when we're trying to do graphics and we need to put a key in, the key has to be on a given line at a given pixel. It does not have the accuracy to be able to do that. So if you look at the little chart here, you can see that, yes, Blackburst is better than 1 microsecond, but the lock is better than 10 nanoseconds if you're GPS locked for PTP. So PTP will take that GPS lock and bring it down to you. But if you are Blackburst locked, it's going to be the 1 microsecond lock for that.
So I hope that explains to people and will give you that sort of information when somebody does say, do I need to deploy a PTP network? Can't we just bolt it on the back of our NTP? There's your answer. So our industry is notorious for being at the bleeding edge of technology, isn't it, Steve?
Yes, it
We
is.
do like to do stuff that other people haven't considered, or if they have done it, they haven't done it with the sheer volume of data that we try and push through. And frequently get asked by people about PTP, well, who else is using it? And fortunately, for once, we're not at the forefront of this evolution.
Not
There
even
are,
close. Not
there
even.
are quite a few industries, some very big ones that have done this before us, aren't there, Steve?
Yeah. The one that rings home to, I think, all of us is all of the cell towers are all connected via PTP. And when you switch driving from one cell tower to another cell tower to another cell tower, that's all done off of PTP. So that's how it walks. And you can walk from cell to cell to cell without even noticing that you've changed cells so many times. Finance. When when somebody is at a trade center and they say, hey, I want to do a buy now, it better get timestamped with now. And all of the trading and financial institutions rely on PTP for that timing to be able to do that stuff. Power grids will use this. Some manufacturing for doing certain things will use this. So it has been around for quite some time. It just happens to fall into the space that as we move to 2110 and IP style environments where we can't put an analog signal over, giving us a timing signal that we can derive every other timing signal we need to be able to derive off of that GPS signal with basically atomic accuracy.
And obviously, the great thing for us, Steve, is that SIMPTE were on board with this very early and identified a number of parameters that we needed in the broadcast industry. And we have a standard, 2059,
Yes.
which allows all of us manufacturers and all broadcasters to work with. You know, it's not a specification, it's a standard, it's black and white.
Yes. So, and the other nice thing about a good SPG is that it has a single oscillator that is that oven controlled crystal, and the GPS is locking that one oscillator. That one oscillator is then used to make the analog bi-level, the tri-level, the test signals, making the AES signals, and then also making PTP for the digital side of the house, and locking all of that to a single clock. That way, if something happens and you do lose GPS, it just walks, it's already on the crystal, doesn't even have to walk over to the crystal. The crystal just goes to what we call holdover or stay in sync. And it's a accurate enough crystal that you are going to stay perfectly in sync. Nothing's going to move within your facility. If the signal comes back, it is a slow lock function that will drift in phase forward or drift in phase backwards at a rate that you don't even know it's drifting. It will not change color hue, will not change audio. It just sits there and just walks itself back perfectly back into sync in the background while things are still going on.
I think this is quite important, Steve, because having spoken to people who've come from other industries where they use PTP, I mean, I think you can comment on the telco ones. Their kind of return to sync you know, is nowhere near as demanding as what we're asking for.
Yeah, a lot of systems will do a 360 hunt when it goes because they want to get back in sync, but they sit there and go find it. And if you do that 360 hunt, you're going to take the video and audio and everything else we have and just send it flailing.
So it's worth bearing in mind because, as I said, you know, a number of PTP equipment manufacturers are looking at broadcast as kind of the next growth area for them, but they don't understand the nuances of what we require as broadcasters.
Yeah, and I've heard horror stories. Don't have the details, wouldn't put them out if I did, even though that some other devices that aren't from the video industry natively lock perfectly together when they're GPS locked, but as soon as GPS is gone, each output has its own oscillator and they all start going wonky off of each other and they don't stay in sync. And then you reapply GPS and they all have to go find themselves again and nothing stays in sync. So with a purpose-built sync pulse generator from a video company, it's much nicer that they're all tied to a single oscillator.
One other thing I'd add to that, Steve, is I've seen, obviously, you know, a number of broadcasters are making this transition from SDI to IP. They're bringing in consultants who, you know, have designed PTP networks. But I would say when you're interviewing these people, find out what their broadcast experience is, because if they've only got telco experience, they are not aware of some of the nuances that we require. And yes, they can design a system that works, but it's when it fails. That's when the challenges come, isn't it, with broadcast systems? Because I use the analogy that basically we have to design a system to fail at the most inopportune moment. And we need to make sure that we've got redundancy in it. It's the Super Bowl. It's 2 seconds to the end of the game. It's tied. It's second and goal. That's not the moment you want your reference to go.
Most definitely. You know, closing ceremonies of, you know, or the gold medal ceremony, you know, race of the Olympics, and all of a sudden, whoop. So that's where tying all of this together and having Black and PTP play well together, because let's face it, we are going to have Blackburst and tri-level around for the next umpteen years. We still want our SDI and IP test patterns to be locked. You know, and the AES where we're making audio, but it's baseband audio. It hasn't gotten into the transport yet, either 2110 or embedded SDI. So we need to make things play well together here.
Yeah. So going back to that point that we expect the most unexpected thing to happen at the most inopportune moment, what we have now on screen is how we kind of cater for that when it comes to our reference signals, by having both a primary and a backup sync pulse generator connected to an emergency changeover unit. And this has worked really well, hasn't it, for us for many years now?
Yes, and it's going to be what we have going forward. But now we also have PTP for the 2110 network, which comes out of the SPG and goes directly into the network, because PTP has their own system for the two SPGs talking to each other, but they're talking to each other over the network.
So let's make this clear to everybody. PTP is not going through that emergency changeover unit.
Nope, it's going directly out to your PTP distribution network. The two generators are talking to each other. Kevin and I have got a couple PTP webinars up if you want to see how that operation takes place and the synchronization between those two. But the two generators are talking to each other. And if you've set the priorities correct, in this case, the top generator would be the generator that everybody would be using for the PTP. The bottom generator is there in waiting if something happens to the top generator.
So what could possibly go wrong? Here we are. Everything's coming off of the primary SPG. Life's good.
And then something happens to your Blackburst going into the SPG, or the output of the SPG could go wonky, but something happens to cause a signal to go. Someone screws up the connector, something happens weird, and we will switch to the backup SPG in the ECO, and life goes on perfectly from all the black aspects. But, Kevin, what happened to PTP?
Well, it's still running on the primary unit because the best master clock algorithm that selects the Grand Master doesn't know what's happened with the emergency changeover unit. It's not part of the process because it's not connected to it.
Oh.
So now you've got the scenario where your Black and Burst and PTP are coming off of different devices.
And
That's not an ideal situation.
Yeah, that could get really strange for the poor maintenance engineer that needs to go in and find out what happens. So he thinks he can go up, since everything's switched, go to the backup. He can go into that primary SPG and start fiddling around and moving things, powering it down, powering it up, and doing things, not realizing his PTP is still coming off of that generator. So there are things that we can do to make things happen. And one happens to be the ability when the SPG swaps over is to actually make the primary unit a different clock priority than the secondary unit, and change its clock priority so that it is not the leader anymore. And the second SPG, because we've made it a better priority than the top unit, you can do it two ways. You can do it, call up a preset that just changes the PTP priority of the bottom unit, make it better than the top unit, or you could actually take the same lead up to the primary unit and make it a lower priority than the bottom unit. And that will walk seamless because it's not a drop in signal, it's just a change in priorities, and all of the devices on the PTP network just walk over, and the SPG just walks from one SPG to the other SPG, still putting out PTP. Nobody sees the thing in the network.
So basically, you've used the emergency changeover unit has triggered the best master clock algorithm to change them, because you've changed the preset, you've changed the priority, and you've raised the level of the backup SPG, so it becomes the Grand Master.
Yep. So now we've got the flip side of this, where something happened to your GPS, took a lightning strike on the antenna, who knows what, maybe the PTP generator, God forbid, in the SPG took a dump. But your PTP, your top generator, is no longer locked to GPS, it's on internal. The bottom generator still locked to GPS, so it's a better, what they would call, clock class, because it is GPS locked versus sitting on the internal crystal. And it will, via the BCMA, best master clock algorithm, PTP will lock to that second generator, which is good. So now you've got the best possible PTP lock, and it's still in your network, but everybody else is still sitting on the top generator for all of your
other references.
other references and test signals and everything else. And again, you can get that same scenario that someone might want to try to figure out, I got to fix this thing, get in there and not realize that if you yank it down, it's going to switch over eventually, but it's going to have to drop before it ever switches. And that is not pretty when black drops. Devices do not like that. So, at least Leader, we've got the ability to link what I call an unused black out. So if you take black 6, there's 6 outputs, and chances of needing 6 individual outputs is slim and none. Take the 6th output of the black, we have the ability to tie that to the BCMA, and we can actually take that 6th black out, have it go away. It's not feeding into your plant. The ECO will then switch to the backup, and now everything. And the nice thing about it is all of your AES and black tri-level signals are all switched electronically, so they're hitless. Nobody even sees them switch. So it doesn't take a relay switch. It is an electronic circuit switch with relay backup on top of that. And now your entire network is riding on the backup unit. Now you can go to the primary unit and work on it.
So that's basically covering both of those scenarios. And as I said earlier on, we have some very unique requirements as broadcasters. And with companies like Leader, with our 70 years experience, we've come across most of them, haven't we, Steve?
We most certainly have, Kevin. We most certainly have. So we have the ability that if we look at our black out, we could take any black out. This happens to be black 1, but we can take any of the blacks and tie them to the BMCA, and the output then will go away, causing that forced switch on that unused output. And then when it returns, you can come in here and return it back to normal. So it makes it really nice. And the other piece then is where, like I was talking about, you can make different presets, and the presets would then have the ability to, here is my change leader preset. So I changed the priority on this generator. When the blacks fail and the ECO takes over and changes, it recalls preset 4, which says, okay, I'm going to go and make myself either the Grandmaster or remove myself from being the Grandmaster, depending on the way you want to set it up. And PTP will walk over as well.
You just want to go into the PTP settings, Steve, where the priorities, the simple place to change those.
So here's the settings from 1 setting. And what we'd do is we'd go into setting 2, priority 2, either make it better than the Grandmaster if that's the direction you want to go, or if you're going to go the other way, you could make it a higher value than the 2nd unit, and then it will walk over that way. So you can call it either way you want to call it, and be able to do that off of the settings.
And one thing people will notice here on the LT4670, we've got 2 independent PTP engines.
Yes, and we also have the ability. So the other unique thing is, since the BMCA is outside, it's on the network, and it's not part of the ECO, ECOs normally switch over. They stay switched until the engineer determines that everything is good, and he says, okay, it's time to go back. Well, typically PTP will walk back itself as soon as the priorities come back on the grandmasters. So we have the ability to say enable only once, and that way when it switches over, you have to bring it back at the same time you bring your ECO back, and it will now come back. It won't flail back and forth, back and forth, back and forth, especially if you had something that's coming and going, coming and going. You've got a GPS antenna that, or cables, you know, that's right on the ragged edge, and it's going in and out of lock, and it'd be switching over, switching back, switching over, switching back. Every time it did that, you can say, nope, you're going to follow the basic priorities that the ECO does. You're going to switch over, and you're going to stay there till I bring you back. So it's kind of nice to be able to have that ability to be able to do this.
I mean, these are features you only find out when you need them when it happens.
Yes. Yeah.
And when it happens, it could take your station down.
So those are the things you kind of need to think about that we don't always think about when installing the sync system. We know we got to set up PTP. We do that for our network. We test the BMCA, make sure it fails. You also need to test that BMCA in two different manners. A lot of people just yank the fiber and drop PTP going into the network, which is a hard fail, and that will definitely switch. But the other thing you need to do is remove GPS, because that's going to verify that your priority ones are set correct, as well as your priority 2, which is going to follow that GPS walkover. And it's a completely different walkover. It's a much cleaner walk because the signal's not going away. The two units are talking to each other, and one unit sees the announce messages and sees that, hey, you're no longer clock class 6, you're clock class 248 because you lost the GPS. It says, hey, I'm still clock class 6, I'm better than you. You be quiet, I'm taking over, and the second unit just takes over. It's a very soft switch versus yanking the fiber, which is a complete LOS, lost the signal.
So obviously, we've been talking about a leader product here. Do you want to pop the next slide up, Steve? Because it gives our viewers a bit more detail about the LT4670.
So this, go ahead, Kevin.
So this is our new SPG. For those familiar, we did have an earlier product, the LT4610, but talking to a number of customers, especially with IP systems, we're becoming more kind of like data centers and that. So things that we've added to this are like redundant hot swappable fan assemblies and power supplies. The ability, we talked about it there, to have dual PTP independent engines, because you may well be running both your audio on AS67 and your video, your 2110, and watch some of our other videos, and we'll talk about the different domains and all those you need on that one as well. But obviously, we've got so used to, in the world of SDI video, having SDI test patterns coming out of these devices, it's only logical that they also output 2110 test patterns. So we've added that to this unit as well. So
Yeah,
I know you've had experience, haven't you, with the IP test pattern, Steve, with a couple of customers now, and it's been very well received.
Yeah, it has. The other unique thing that Kevin talked about is, yes, we got hot swappable redundant power supplies. Those have been around for years, but switching power supplies continue to get better and better and better, last longer and longer and longer. The thing that I had several people at this last NAB tell me is they're losing fans more than they're losing power supplies these days. We have hot swappable fans. You can swap out one of the fans without taking the unit down, 2 little thumb screws on the side, you undo them, pop the fan out, pop a new fan in, tighten up the thumb screws, and you have a new fan. So we can do that with the front fan as well as the rear fan, which is incredible since those, are running 24/7, and the bearings can go bad in them and they can die on you. And you don't have to take the unit down to open it up inside to go swap a fan out. So here's just a real quick picture. We don't want to make this a complete sales presentation here. We primarily want to stay technical for you and present things. But as Kevin said, we've got a couple different options here. We have just a pure SDI output, or we have a 12G, 4 independent 12G capable outputs and 2 independent, or we can make them -7 25G outputs that we can put out test patterns in the 2110 domain, as well as all of the normal things you'd expect: blackouts, the AES outputs, the GPS coming in.
And the 4670 works with our existing changeover unit, the LT4448. So,
So we want to thank you here, and
yeah, I think we've been going on for long enough. I've noticed in the chat there's been some bits popping up. So Cindy, you're on point.
Hey.
you got
What have we
a
got?
couple questions. We may not get to all the questions within this session, but anything we don't get to within this session, or we really have to do a little research on and come back to you with, we will answer 100% of all questions via email.
True. We'll circle back with you with answers to everything that you want to know about. And let me pass you a couple questions right now, Kevin and Steve, and see if you want to go for those. And then, like you said, the rest of them will come back to.
Certainly.
What recommendations do you have when you have a facility that's got a combination of networked PTP and tri-level sync Blackburst?
So run that one more time.
Do you have recommendations on how to manage a facility that's got that combination of networked PTP, tri-level sync, and Blackburst? I feel like you talked about it in your diagram a little bit, but just wondered if you had a point to bubble.
The biggest thing I would tell you is your Blackburst is probably already in place. You're bringing PTP in for the GPS lock and the PTP. I highly recommend migrating your black and tri-level to the unit that's providing the PTP, because if you lock your PTP off of your existing black and tri-level, it's a clock class 248, which is talking about the quality of the lock, versus if you're GPS locked for the PTP generator, that's a clock class 6. And that's as close as you can get without being an atomic clock. So your PTP is going to be a much, much higher clock class being locked to GPS than it is being locked to tri-level. Now you can take the output out of that generator and then lock the rest of your facility, but it's best to migrate back into that new generator from your old sources. And again, that way, if anything happens, everybody's contained on that one set of SPGs, the primary and the backup, and your changeover, and you aren't going out to multiple sync points to have multiple failures and cause issues trying to troubleshoot.
That was great. Thank you. Another question is, are there timing correlation complications in locking sender and receiver to different GPS constellations?
None whatsoever.
Love that. Love that. And a request here for a PTP best practices document. Would that be something that there's a standard to refer to or something else? What do you think?
I don't really have. Go
well,
ahead.
as I said, if you visit our YouTube channel, we actually have a playlist on there, Essential Guide to PTP. And Steve and I know that several customers have sent their engineers to watch those 4 or 5 videos before they even do put their first product in place and put that first network cable into the switch, so that they understand what they're designing. Because if you design it wrong at the beginning, there's no getting it back. But if you design it right in the first place, this will scale for you. This will give you all the benefits that, you know, the IP Nirvana is offering you.
Yeah.
But build your PTP correctly, you've got a solid foundation. Do it wrong, and you're building your house on sand.
Yeah, it's hard to go backwards, especially in a live production scenario.
Yeah.
No one ever wants to play with their timing source after they've already put it in.
So, Steve, I think
so painful.
I think the next slide has got a link, hasn't it, to our the YouTube channel? No, next one. Well, there we go. So, if you're not already registered, as I said, the Essential Guide to PTP playlist is up on our YouTube channel. Along this video will be up as well pretty soon once we've got it done. And if go there, have a look, you're going to see there's some interesting stuff. If you think there's a subject that's not covered or something that needs explaining, Steve and I are more than happy to have a chat, even put together a video on it if enough people ask us.
Definitely.
And I'll make sure the links are in we'll send a follow-up email with the replay out, and I'll make sure that you've got links to the videos that you mentioned there. Thank you.
You can send the Leader YouTube homepage and the US Leader home YouTube.
We'll do.
It was a shame. It was a shameless plug, Steve, because I'm here in Europe.
Yeah.
And finally, to mention,
yes,
obviously we're over here in Europe, and it's that time of the year again. IBC in Amsterdam, where we will be showcasing the LT4670. It will be running the Leader booth in the convention center. So we'll have it hooked up, doing various little different things and tricks to show off those features and functionality that you may not have known you actually need.
Yes. So you can click the QR code, take a picture of it, and click into it, or just take your camera and click into it if you want to book a demo. But if you've got questions and you are coming to IBC, please stop by. Kevin and I will be there, and we can answer, hopefully, any question you have.
And we've got a link in the chat as well for booking a meeting too. So whatever type of tech you like.
Yes. And we want to thank you for joining us. We hope this was enlightening and made you start thinking about things that a lot of people don't really think about when they start building these networks. That some of the idiosyncrasies of, hey, I can be running on this generator for part of my network. I can be running on this generator for a different part of my network. And yeah, it can get really messy from a maintenance standpoint.
Yeah. So thank you everybody for joining us. As I said, we will return after IBC with a yet to be decided subject. So watch your email inbox if you're registered with us. And thank you once again for your time.
Yes, I hope this was beneficial for you folks. Please let us know, because we put these on for you guys. So we just want to be able to put out information that is meaningful and useful for our customers. So thank you very much. Cindy, Fallon, both of you too.
Thank you.
Stellar is normal. I want to thank you, and we appreciate all your support. And
Thank
Kevin,
you.
you and I'm sure, as we start getting into more of the engineering backroom details of IBC, we'll be chatting quite a bit. So
Oh, yes.
I look forward to seeing you at IBC, dude.
The challenge I have, Steve, is that your equipment room at NAB was so tidy and clean. Again, go on the YouTube channel. There is a video of Steve's office from NAB. How he got away with it, how he did it, I don't know, because IBC never looks like that.
Well, thank you, Kevin. Everybody, thank you very much for attending.